I wanted to demonstrate a couple normal projects, but first I want to show you something from today's news, which I thought was very interesting and right on target. It's what we're going to do in a week or two. Oh yes, and don't use the Flare VM. I'm glad you pointed that out. I used the Flare VM in previous projects. For all the projects we're doing this semester, just use this one here, Windows 10 with tools. I'm glad you mentioned it. The Flare VM keeps changing. And even though some of the projects refer to it, the current version doesn't have the right tools, so I wouldn't waste your time on it. Just use this Windows 10 for everything. I'm glad you mentioned that so I can get that on there. Anyway, let's take a look at the news. And this is it. Someone put this on Twitter. He said, every Electron application on Windows has the same DIL hijacks. And I don't really know what Electron is, but apparently it's a programming framework used by a lot of things like Slack and Discord and Signal and so on. And he says they have all of these. And I thought that was very interesting because it's very easy to tell. And I'm just going to demonstrate this. This is something we'll do in official projects in a week or two, but you might as well see it now. All you do is use Process Monitor. And this is how you can see how Windows works. And let's see if I can make this fill the screen better. Come on. You done messing with me or what? There we go. Oh, it's going to keep this ratio the same, which doesn't make a lick of sense in a virtual machine. Oh, I probably killed VMware Tools. Yeah, I'll just leave it this way. There's probably a reason for that. Anyway, so you run Process Monitor, which we're going to use later, one of the sysinternals tools. And Process Monitor lets you see what's happening. And I'm going to launch Slack. I downloaded and installed Slack in the VM. And I'm going to look at every process where the name contains Slack and where the path to the executable ends with DIL. So what we're going to see is how Slack refers to libraries. And the Process Monitor is running, see 50,000, 60,000, 70,000. It's running, looking at all the Windows events. And now we're going to run Slack. So I'll make this a little smaller. All you do is launch Slack, and it records all the references to libraries that Slack makes while loading. And then I'm going to stop sniffing because Slack is up. And now we can see vulnerabilities in Slack right here. And we are going to exploit these vulnerabilities in later labs. Notice right here, it looked for something and didn't find it. Wow64 log. But it looked in a Windows system location, which is a good place. So that's not exploitable the way I'm looking at. But look at this. Here it's loading a library from C users, IE user app data local. This is an area that's writable by the non-privileged user, looking for some ffmpeg.dil, which was there. So this would suggest that this ffmpeg is some library that is not commonly included in Windows, and Slack included it as part of their app, so that's all right. But look at this one, UI automatic core.dil. It looked for it in the Slack local unprivileged location and didn't find it, and then it went and looked in C Windows System 32 and found it. So this is an error in Slack. This shows that Slack tries to load a Windows system library from the wrong location, and when it doesn't find it, it goes here. So I would be able to have malware that did not run as a privileged user that put a library here in this unprivileged location, and this app would load it thinking it was a Windows system library. And this is how you perform privilege escalation, and we'll do this in the later projects. And as he points out, there are a ton of these with this problem where name is not found, like debug help, and it's a real Microsoft system library. It shouldn't be looking in this stupid location for them. It should go to the C Windows System 32 for them, but a bunch of the libraries in this app do not do that, and apparently all those other apps have the same flaw. And we're going to exploit an app with this flaw in a project in a couple weeks. Anyway, it's a very easy flaw to find and a very easy flaw to exploit. So let me make a separate video.